All righty. I hope everybody is having a great day today. Hopefully free of tech glitches. Now tech does the most sometimes. Alrighty, so for those of us that were a little later coming in, which I think everybody is in our pair deck, but if you are a little late coming in, I will put it in the chat so that way you can have access to it. There it is. So if you need it, you can go ahead and log into it. We're going to go ahead and get started. So today we are going to be talking about experiment replication. So the first thing I need you to do is in the box that is in your pair deck, I need you to answer this question. Has your math teacher ever told you to check your work? If so, why do you think they did that? Type your response in the space that is provided. So I see a lot of good answers in the chat, in our Nearpod box, shall I say. I have about 18 people that haven't started typing your response. So please make sure you are doing that so we can get our participation points for the day. All right. So the answer I'm saying are to make sure that we did not do our work too quickly and miss a step, to see if we understood the steps we needed to take to get to the answer, to make sure we got the answer right. So you could see if something was wrong within your work, to make sure our answers are correct, to make sure that we're doing our steps properly, to make sure we have the correct answer and didn't type the wrong thing in on accident. All right. Give it a few seconds so people can finish. Alrighty, so this was a little bit of a trick question because yes, I already knew the answer to it. Yes, your math teachers have told you at some point in time that you need to check your work, because if you are um, adding numbers or multiplying numbers, you are doing repeated calculations, and sometimes you may end up with a different answer. So you need to make sure that you are getting the same answer the second or third time that you are doing it. So we do this in science as well. It's not just a math thing. If you get the same results twice, then that means that you're probably correct. This is why majority of the times when we do trials, we do them in odd numbers, usually in sets of 3, maybe even sets of 5. But this is because if you get the answer the first 2 times, the same answer the first 2 times, then you know that it's probably going to be correct. But if you get 2 different answers your first and second time, then you're probably going to need to do it again a third time to see which one is actually correct. So that's the reason why we do it. So today we're going to go ahead and start taking our notes with replication. They just name it replication. You can put them underneath where we wrote our trial notes. If you have room, you do not have to use a whole piece of paper because they're not super long today. So with replication, this is when you have the results to your experiment or whatever that you are doing. You usually give them to somebody else in the scientific community, usually another scientist. They could be on your team, they could be on another team that's investigating your results, but they are going to try to get the same exact results for the experiment that you did by repeating your experiment. This is what replication is. All right. Give you guys a few minutes to write that down. If you're joining us after the slide, I just put the link to our Pear Deck presentation in our chat box if you need it. Once we're finished, go ahead and type done so that way I know we're ready to move on. See a lot of done's coming through. All righty. So our next discussion piece that we're going to have, I want you to tell me, what do you think the difference is between replication and repetition? What is the difference between replication and repetition? So I'm seeing some IDKs, which is okay. One is copying, one is repeating. Okay. About 25 people that have not responded. People typing random letters. I'm not sure what that is. Okay. See, a lot of us are kind of on the right track. A few people that are finishing their statements, and then we'll move on. Alrighty, so what we're going to write in our notes, we're going to copy this chart. Repetition is multiple trials in an experiment. So when we did our paper airplane lab experiments last week and earlier this week, you should have thrown each of your paper airplanes 3 times. That is repetition. We're trying to see how precise our measurements are, how close they are together. So that is the repetition piece, the retrying of your actual experiment. Replication is when you have a peer redo your experiment, and that's going to measure how accurate your original experiment was. So today, that is what we're going to do for our asynchronous or our practice time, is we are actually going to replicate a peer's experiment. So I'm going to give you a few minutes to copy this down. Once you are finished copying it down, go ahead and put done in the chat so I know we're ready. I know it's not going to be any time right now because you guys just got started. That's perfectly fine. But just when you guys get to that point, type it in the chat so I know we are ready to move on. All right, so I'm starting to see some dones pop up in the chat. All righty, does anybody need more time? Seeing a lot of dones pop up. Alrighty. So the last thing that we need to write down, and we will be done with our notes today, is the why. Why do we need to replicate an experiment? The answer to that is because when you do repeated replication of investigations and when other people repeat those investigations, those can turn hypothesis into theory. So you can have an idea of how to solve a problem and what you think is going to happen, and then you can make your hypothesis from it. Once a bunch of people start doing your experiment over and over again and they see that that's the case just about all the time, then it can change into a theory or a law. Now the difference between a theory and a law is that a theory is an ideal that is backed up by scientific principles. It leads you to believe a certain way, but there's no way to concretely back it up and say that this is what it is, versus a law that has a lot of science that backs it, and we can say beyond a shadow of a doubt that this is what is going on. So with like take Newton's laws of motion. Laws are for every action, there's an equal and opposite reaction. That is the principle that seatbelts work with. You have objects in motion will stay in motion unless acted on by outside force. So if you look at, excuse me, the planets and the moons and how they revolve around the sun, that proves that law. It happens all the time. So unless like a meteor or something like that hits a planet or a moon or something like that and knocks it off course, it's going to keep going in the same pattern at the same velocity unless something happens to it. Now, a theory, on the other hand, would be something like why the dinosaurs went extinct. There are different viewpoints on how that happened, but there was nobody there to record and say this is what happened, so we know beyond a shadow of a doubt. So it could be some people think an ice age happened, some people think that maybe a bunch of volcanoes erupted and wiped out the planet. Some people think that an asteroid might have hit and not wiped out the dinosaurs, but there's no way to beyond a shadow of a doubt say which one of those happened because nobody was there to record the information. Scientists can look at like fossil placement and things that they find around the fossils and analyze soil samples and ice samples and come up with an idea of what they think happened, but there's no way to know for sure what happened to them. All we know is that they're not here anymore. So that is why we have to replicate experiments, so that way we can see if they're proven beyond a shadow of a doubt. And that's it for notes today. So next, I'm going to read you a scenario, and I want to know your viewpoints and your thought on the scenario. It is: in 1998, a British researcher published an article in a medical journal reporting that he had found a link between a common childhood vaccine and autism. According to the article, children in the study developed autism soon after receiving the vaccine. According to the publication of the article, many parents refused to give their children vaccinations or get them vaccinated. Several epidemics occurred as a result, and some children even died from the disease. Soon after the original study was published, other researchers tried to replicate the research. However, it could not be replicated. No other studies could find a link between the vaccine and autism. So what your job is, if you look at the screen in front of you, you should see correct or incorrect. And I want to know your viewpoints. Do you think that the initial findings about the connection between vaccines and autism is correct or incorrect? Just drag the little icon, this little blue dot at the bottom. Just drag it where you think it should go. I have about 10 people that haven't responded yet. Ooh, this is interesting. Allison, you are correct. All right, so let's look at the results. The results are that scientists became convinced that the original results were incorrect. Eventually, investigators determined that the original study was a fraud. They learned this because the author had pretty much received a large amount of money to find evidence that the vaccine caused autism. So he faked all of his research, and the other scientists were able to figure that out because they replicated his research. If they never did that, then the truth might not have come out, and people would still be thinking that that was the case, but it was not. So you said that that the study was incorrect, then you are correct. All right, so what we are going to do, I am going to put you in breakout rooms, in random breakout rooms. And what you are going to do is answer these four questions with the people that are in your room. You will all have the ability to unmute yourself so that you can talk, and this works a lot better if you do talk to each other. Work together and fill it out. What we are doing, you're going to put a text box in there, or you can draw if that's what you would rather do. But I need to know, what is replication? Why is it important in science? Why do you think so much effort is made to replicate the vaccine study? And what was the outcome of the additional research? You're going to have about 4 minutes in your breakout rooms, and they start now. Um, Michelle, you should be in breakout room 4. Octavia, you should be in breakout room 2. All right, so if you are in Canvas, so you need the Canvas tab, we're going to go to Modules, and we are going to go to the bottom of the scientific method. Tomorrow will be the last day that we will be doing scientific method stuff, because we'll be moving on to geologic time scale. So this will tomorrow's activity will be the last thing that we'll be doing in here. Your notes that we took today, you're just going to take a picture and upload them to this assignment. Oh, I'm not even sharing my screen. No wonder you can't see. Sorry. Um, so once again, from your home screen, when you log in, you go to modules, and then you scroll down to the bottom here. Your notes will be getting turned into this assignment right here, your replication notes that we took today, and your lab replication is what we're about to talk about. So just like we talked about in our notes today, how scientists have to retry people's experiments to make sure that they got it right and to determine if it's going to be valid or not. So what you are going to do is you're going to pick one of these 6. You only have to do one. These 3 measure distance, these 3 measure time, and you are going to replicate their lab. You're going to do everything that's in their lab, write up, no more, no less, just exactly what's written there. And when you are finished, you are either going to create a flip grid or a written response that explains how you replicated the experiment and your experience with it. So was it hard to understand? Were the directions easy to follow? How was your experience with it? If you decide that you want to make a flip grid, which is a video, you click here, it will open the flip grid for you, and you just record your video, and you're going to post it right here. If you decide that you want to do the written version, if you come up here to the top where it says submit assignment, there's a text box entry. All you have to do is type whatever it is that you want it to say, and you're going to hit submit, and it will be turned in. If you do the flip grid, once you turn it into flip grid, it will come to me, and that will be your submission for it, and I'll just bring the grades over here to Canvas. And that's all we're doing today. So you literally have the rest of the class time to work on either figuring out what lab you want to replicate, and going ahead and making that airplane to do it. You really only have to make one in your replication. You don't have to do all 3. To do whichever one you want to do. And if you are not quite finished with this slide, you need to make sure that you get finished with this before you leave, because it will be reset for next block in about 10 minutes. All right, if you are done and you want to replicate on your own, you are free to go. Have a great day. If you have questions, stick around and you can ask your questions, and we will go from there.